start again. Okay, thanks. This is the Tesla model. So this is the AC. You can see the yellow, and you can see the kind of like a sine wave here, represent just the AC symbol. And it will come out here. And of course, if I now, without the transformer, if I switch on this, I did not touch this. All right, trust me, I did not touch this. Okay. If you don't trust me, I can plug this again.
Can we trust you?
I don't want you to trust me.
Oh, okay.
Yeah? A little bit dim, right? So if I now change it back to AC without the transformer, you can still see it's a little bit dim. Basically the same as DC. So without transformer is actually useless. It's not only the main thing is it's not only about AC, but AC with the transformer, right? Okay. So now I'm going to connect it with the transformer.
Stop.
Look carefully of how the connection is made. Before I go into the power cables, we need a transformer. If you have been hiking before, of course, you will see those power stations. Like it's always nice to teach in this room because you can just see it outside. Usually they would have a sign. What sign is it? Dangerous because what?
High voltage.
High voltage. Very good. Remember that high voltage. So what you do is you need to use a transformer to make the voltage to be high. All right, just fit with the reality. But we will explain why later on. When we do calculation, you see why. Why high voltage? Why not low voltage? Actually, low voltage, you're going to make it worse. High voltage, you make it much better. Later on, you'll see. So what we do is, I've got the transformer here. I can let you pass around as well. You can see mainly there is a number here, 1,500 here. Do you know what they mean?
Turns.
Very good, numbers of coil. You can see here, transformer is no more than just coils, but a pair of coils. You can see one here and the other here. The blue thingy is called the soft iron core. If you remember when you build the electromagnet, you need to put an iron nail. If you ever try to pull it off, the magnetic field is much weaker. So that's why we use this to strengthen the B field. But basically it's this one. I can let you pass around. You can try to compare that. One is heavier, one is lighter too. Just because one have more coils and one have less. So what I do is, I'll keep this the same, but before that, I'll go into the 50, that one first. And the other side is also 50. So you can see that, you guys can see that when we get it out from the power station, they just connect it to this point.
I have no idea.
And the other side, what we will do is we will get the cables from 1,000 that one to the other side. Okay? So as we said, it's supposed to be high voltage, right? If I set this as 3, can you guys guess? If I set this output as 3 at the beginning, what is the voltage after the transformer? Transformer is 50 and 1,000.
50 and
60. Why 60? Very good. Actually, the ratio of how much you step up, that means increase the voltage or step down, depending on the numbers of coils. I'll explain it to you why exactly. But you can rely on that. That is 50 and 1,000. So the ratio is 1 to 20. Right? Quick maths, 1 to 20. 20 times 3, 60. Right? So supposedly you should have 60 volts here. Not as high as 1,000 because it's quite dangerous. Last time I almost get shocked. I did actually in the other class. A bit painful, and then I just tweak a little bit. 60 already is quite exciting.
Let's take it.
On the other side, so remember these are the cables. Again, I did not turn it anymore. It's the same resistance. I will never touch it again from now on. On the other side, what I'll do is, after the cable, I will need to step it down. Imagine if you get those 1,000, actually not even 10,000 volts from the socket. You basically set yourself on fire at home, right? We have to step it down in this case. So what we need to do is simply connect to the transformer, but this time we connect to 1,000 first. Why?
Step down.
Yeah, you step down. So you go for the high number first, and then you output with the small number. So the light bulb, so the light here connected to 50 only. It should step it down. So supposedly, if I use this setup, how much V is here? It's the same. So how much? 3. Because back here is 1/20 times. So back to 3V. Okay? Are you all okay with this? Again, I did not touch this. Now is the moment of truth. If I switch on this, and we want to see the brightness to be what? Hopefully the same. Okay? 3, 2, 1. 1V, 2V, and 3V.
Wow.
Not exactly the same, I would say, but much brighter than the Edison, that one. And you see, just now, really, the transformer is helpful. It's very important. Without this, we can't do anything.
Why can't we use DC transformer?
I will show you very soon. But now, I want to show you the voltage first. Can we split another video again?